Okay, today we're going to look at section 10-2, simplifying radical functions or expressions. Now, we have already looked at this when we did quadratics. It was one that I showed you, and I told you didn't have to do at the time because we would learn it later. So we're going to learn it now. What I would do is start off with a list of perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. That should do it. And you're going to use this list, so you'll want to keep that out. And what we're going to do is we're going to take a radical that is not a perfect square, that's not on this list originally, and we're going to simplify it, get it in its simplest form, kind of like reducing. So let's take the radical square root of 54. Okay, now, so what I'm going to do is I'm going to look over here at this list, and I'm going to say, all right, what is the largest perfect square that will divide into or be a multiple of 54? So I can say, okay, 4 will go into 54. No. 9 will go into 54. 9 times 6. So let me come over here because 6 is not a perfect square. So the square root of 9 is 3. So it comes outside the radical. Anything that's not on the perfect squares list stays under the radical. So 3 square root of 6 is the same thing as square root of 54. Let's try another one. All right, let's do the square root of 180. Okay, 180 is not on a perfect squares list. If we were to keep going, this would be like 169 and then so forth. 180 is not on the list. So I've got to think of a perfect square that's going to go into 180. Now, let's try 9. 9 would work. It would be 9 times 20. But there's a perfect square that's greater than that that will go into 180. All right, let's try 36. Will 36 go into 180? 36 times 5, I do get 180. So we're going to do square root of 36 times 5. And then the square root of 36 is 6. Since if it is a perfect square, it comes to the outside of the radical. It's no longer under the radical when you take the square root. And then leave the square root of 5 in. Another way you can view this, if it would help you understand it better, think of it like this. When you see square root of 36 times 5 under the radical, it's the same thing as saying this. The square root of 36 times the square root of 5. You can distribute the square root. Therefore, the square root of 36 would give me the 6, and the square root of 5 is just brought down. When you see a number directly beside the radical, it indicates multiplication. So either way that you think of these is fine. Just choose one that works best for you. I'm going to move this paper up, so you'll have to look at your own perfect squares list to complete the rest of this notes. So let's just do one that's kind of simple. Let's do the square root of 24. What is the largest perfect square that will go into 24? That is going to be 4 times 6. The square root of 4 is 2, and the square root of 6, the 6 stays under the radical because it is not a perfect square and it can't be simplified anymore. So this would be our final answer for this one. Now, let's do one where there has the radical has a coefficient on the outside. So let's take 3 square root of 16. Now, square root of 16 is on that perfect squares list. If we look back at our list, yep, I don't need to break it down. I could if I wanted to, but I don't need to because I know the square root of 16. It is 4, so you can take this, and this means 3 times the square root of 16, which is 4, which would be 12. Okay, let's do another one like that one. 2 square root of 25. Okay, 2 times the square root of 25, which is a perfect square, which is 5, is 10. So those work out really nice and simple. Now, let's go a little bit further. And what if we are going to multiply two radicals? The square root of 10 times the square root of 14. All right, if we want to multiply radicals, all we need to do is to multiply the two numbers together and put them under one radical. You can certainly simplify first if possible, or simplify at the end. A lot of times I will just simplify at the end. So 10 times 14 is 140, and it all goes under one radical. Then I go back to my perfect squares list, and I'm looking for a perfect square that will divide into 140. Okay? So we're looking for something that will divide into 140. So will 4 go into 140? Okay, let's check and see. 4 into 140. Over to the side, if you need to do that, that's fine. 3, and then that would be 12, 20, 35. Yep, 4 times 35 is 140. Sometimes you may have to do the math to the side. Okay, and then the square root of 4 is 2, and then 35 is left under the radical, not on my perfect squares list. So this would be my final answer for that one. Let's try another one with multiplication. All right, let's say we have the square root of 3 times the square root of 18. Okay, so we're going to do 18 times 3. If you don't know it right off the top of your head, do some scratch work. Don't use a calculator. 18 times 3 will give me 8 times 3 is 24. Carry the 2. All right, we've done this one before, 54. So we found a perfect square a while ago that would go into 54, and that is 9. 9 times 6. The square root of 9 is 3. It comes to the outside. Square root of 6 stays under there, and it's complete. Okay, let's do one more of multiplication. 3 square root of 10 times 4 square root of 10. Oh, I like this one. You'll see why in just a minute. There's two ways we can actually work this. When you're multiplying radicals and you have coefficients here, 3 and 4 would be our coefficient of the radical. You are going to multiply those outside numbers together. So I'm going to multiply 3 times 4, which is 12, and then multiply my radicals together because it's like they're matching terms. And that would be the square root of 100. Now the square root of 100, if I look at my list, it's on there. 10 times 10 is 100. So I need to do 12 times the square root of 100 is going to be 10. So that would be 120 as my final answer. You could have also recognized any radical times itself. Square root of 10 times square root of 10 is just 10. Or you certainly can take this middle step as well. It doesn't matter. All right, in the next video, we'll be talking about taking the square root of numbers and variables.